Hello everyone and welcome back to another math video. In this video we're going to talk about polynomials. So we need to first talk about what is the definition of a polynomial. So we're going to have a sub n x to the n. So this a sub n, just think about it as just a regular number. And then this is an exponent on the x. And then a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2 plus all the way down to a sub 1x to the first plus a sub 0, and I'll call that a naught. So if it's written in standard form, it's going to have decreasing exponents. I'll abbreviate exponents exp. So decreasing exponents. One thing I want you to know about a polynomial is that these numbers in front are called coefficients. And if we're talking about a polynomial, those exponents must be whole numbers and they've got to be positive or they could be zero. We talk about terms. Okay, terms are the items that's inside of our polynomial. Terms are separated by pluses and minuses. So this would be a term, that a sub n x to the n. The next term is a sub n minus 1 x to the n minus 1, and so on. When we talk about the degree is going to be the largest exponent that we see. So let's look at a few examples. So we have a polynomial, 5x cubed minus 7x squared plus 4x minus 9. Okay, it's a polynomial. All my exponents are positive whole numbers. The exponent on that x is understood to be a 1. And that minus 9 we could think about as minus 9x to the 0. Because remember we said x to the 0 is really 1. So if we look at how many terms we have, that first term is going to be 5x cubed. That second term is going to be a negative 7x squared. The third term is a 4x. And that last one is just that number, negative 9. So let's look at coefficients. Coefficient is a number that's in front of the x term. It's attached by multiplication. So here my coefficient is going to be 5. And the degree of that term is going to be 3. The next term is a minus 7x squared. So the coefficient is negative 7. And the degree of that term is 2. The next one is a 4x. The coefficient is 4. The degree would be 1. And that minus 9, we're going to think about it as minus 9x to the 0. So that coefficient would be negative 9, and that degree would be 0. So I can talk about the degree of each term. Now, if I talk about the degree of the whole thing, I'm looking at the biggest exponent that's in that whole thing. And the biggest exponent would be 3. So we would say that's degree 3. We could also talk about something called the leading coefficient. I'm going to abbreviate that, lead coefficient. So the leading coefficient is the coefficient of the leading term. the leading term is the term with the biggest exponent. So my 5x cubed is the biggest exponent. The leading coefficient there would be 5. We could do the same kind of analysis for the next one. We have 8x to the fifth minus 3x squared plus x minus 10. So my first term is 8x to the fifth. That coefficient is 8. The degree is 5. My next term is the minus 3x squared. Notice I'm keeping the sign with that. The coefficient is a negative 3, and the degree is 2. The next term is a positive x. There's an understood 1 in front of that, and the degree is understood to be 1. And then the last term is a negative 10. That I can view as negative 10x to the 0. So the coefficient is negative 10, and the degree is 0. If I'm talking about of the entire polynomial, I'm looking for that biggest exponent. So that biggest exponent is attached to the term 8x to the fifth. So my degree is 5. And then if I talk about that leading coefficient, it's the coefficient for that term, and that term is 8. So I want to do another one. And I just want to talk about the degree and the leading coefficient. So let's just include a little example here. Let's say we have 7x squared minus 8x to the ninth plus 10x plus 3. And all I care about are the degree and then the leading coefficient. So I'm thinking about what my leading term would be. Now, in this example, notice that the exponents are not in descending order like the other ones. So we could really view this as a minus 8x to the ninth. Notice I kept that sign with it. And then we have a 7x squared term, and then a 10x, and then a 3. So my degree is the biggest exponent that we see. My biggest exponent is going to be a 9. The leading coefficient is going to come from that coefficient of the leading term. And we got to think about the leading term being written in standard form. That's going to be a negative 8 for that guy. So if we want to add or subtract polynomials, we add like terms together. So let's look at that first example. We have 3x squared plus 5x minus 7 plus x squared minus 2x plus 4. So like terms means that the x term has to match. So I've got an x squared here and an x squared here. So I've got 3x squared plus x squared, which gives me a total of 4x squared. And then we're going to combine x's together. So notice how I kind of squiggled under the x's because I know they're like terms. So I have 5x plus negative 2x, which gives me a 3x. And then I have just the numbers I got to put together. So I've got negative 7 plus positive 4. Negative 7 plus 4 is going to give me a negative 3. So there is my simplified version. Subtraction, you have to be careful with the negative. So that negative here is understood to be a negative 1 that we would distribute to all the terms. So I'm going to first do a rewrite. So I have 6x cubed minus 7x to the fourth. Just kidding, 6x cubed minus 4x squared plus x. And I'm going to distribute that negative. So I'm going to have minus 2x cubed minus 5x squared plus 3x minus 8. And then we're going to combine like terms. So I've got 6x cubed minus 2x cubed. So those are like terms because they both have that x cubed. So that's going to give me a 4x cubed. And then I'm going to do a squiggle under the x squared. So negative 4x squared minus 5x squared is a minus 9x squared. And then I'm going to use different colors for the x's. So I have a positive x plus 3x, which is a 4x. And then we have just that minus 8 on the end. There's no other just plain number in here. So I'm just going to have a minus 8. So if I subtract 6x cubed minus 4x squared plus x minus 2x cubed plus 5x squared minus 3x plus 8, that's going to give me 4x cubed minus 9x squared plus x minus 8. This is where you may want to pause the video, try, come back and check your next one. In the next one, we have 7x squared minus 3 minus the quantity minus 2x squared plus 5x minus 6. So we're going to start by distributing that negative. So I have 7x squared minus 3 minus negative 2x squared makes that a positive 2x squared. Minus times that 5x gives me a minus 5x. Minus times that negative 6 gives me a positive 6. Now we're going to combine terms. So I have 7x squared plus 2x squared, which is 9x squared. And then I have a minus 5x. And then I'm going to put those numbers together. So negative 3 plus 6, which is going to give me a positive 3. So let's do one more example. What if we had x squared y minus 2x y plus y squared minus negative 3x squared y minus 2xy minus y. Let's do a 7y squared. So even though we've got multiple variables in here, same rule is going to apply. We've got to apply like terms. My first step is going to be to distribute the negative. So I have x squared y minus 2xy plus y squared minus negative 3x squared becomes a positive 3x squared y. Negative times a negative gives me a positive 2xy. And a negative times a negative again and gives me a positive 7y squared. And then we're going to combine like terms. So even though there's multiple variables in there, the process is the same. Let me find my page I was on. Sorry about that. All right. So I've got an x squared y. So I'm looking for another x squared y. So there's one there. So I've got x squared y plus 3x squared y, which is going to give me 4x squared y. And then I've got a minus 2xy plus a 2xy. So that's going to zero out. So I could think about 0xy, or I could not even write that since it's 0. And then I've got a y squared here and a 7y squared here, which gives me a total of 8y squared plus 8y squared. So I can think about that as 4x squared y plus 8y squared. Now let's talk about how do we evaluate a polynomial. Let's say we have a polynomial and they're using f of x notation. And all that means is it's a function, which means each x is going to correspond to one y. We'll talk more about functions later. Let's say we want to evaluate at a particular x value. So all that means is I'm going to plug in 4.2 for all the x's in this problem. So I'm going to have 2 times 4.2 squared minus 3 times 4.2 plus 5. And I'm literally going to use my calculator and type it in just like that. 2 parentheses 4.2 squared minus 3 parentheses 4.2 plus. And when I do that, I did that off screen. I got 27.68. So that's going to be a corresponding y value for that particular x value on that particular graph. Okay, those parentheses that we put around our x value is going to be really important when we use negative. So let's say we want to evaluate the next one. We have f of x is equal to negative x cubed plus 4x minus 6. They want us to plug in a negative 3.4. So we're going to do the same thing. It's going to be negative, parentheses, negative 3.4 cubed plus 4, parentheses, negative 3.4 minus 6. And I'm literally going to plug that in the calculator just like that. So I have negative parentheses, negative 3.4, close parentheses to the third, plus 4 parentheses, negative 3.4 minus 6. And when I did that on my calculator, I got 19.704.